What is the value of? So we have 1 plus 8 plus 27 all over 6 squared, which is 36. The numerator looks to me like 36, and therefore this just ends up becoming 1. Mike bought 2 books from the Canadian Super Mathematics Company. He paid a full price for $33 per book, and he received 50% off the full price of the second book. In total, he saved 20% on his purchase. In dollars, how much did he save? So we have $33 for the first book, and in the second book, I'll say that the price is P, and he basically paid 50%, so P divided by 2. And what that resulted in is him saving 20%, so he really just ended up paying 80% of the value of the books, which are 33 plus P. So I believe this is the equation that we will use to solve for something eventually. How much did he save, I guess? Okay, so let's do this math here. So we have 33 plus 0.5 P, and this is 26.4 plus 0.8 P. And then this becomes 6.6 is 0.3 P, and therefore P is 22. Now, 22 is not the answer that they're looking for. They're actually looking for how much did we save? Okay, well, let's talk about this. The regular price of the books would be 33 plus 22, which is 55. Now, he saved 20% of that. That's what the question tells us. So he saved 20% of this. So 20% of 55 is basically 0.2 times 55, and that is 11. So 11 is the answer to this question. How many different lists ABCD of distinct odd positive integers with A less than B less than C less than D have the property that A plus B plus C plus D is 24? Well, odd positive integers. Okay, so let me just list them. 1, 3, 5, 7, and so on. And then I think this is just a fiddling around with these numbers. I don't think there's any real mathematical formula. Or maybe there is, who knows. But all I know is that A plus B plus C plus D has to equal 24. So I can sort of, obviously I don't need to worry about any numbers greater than 23. Okay, so let's see here. 3, 5, 7, 9, that would do it. That's 8 and 16, yeah. So then that's it. You just have to fiddle around with this. And I think at this point, you'd have to go down to a 1, since I don't think I can go. If I go anything greater than these, you'll get a number greater than 24. And then 1, 5, 7, 11, 1, 3, 5, 15, 1, 3, 7, 13, 1, 3, 9, 11. So these are the ones, and there's 5 of them, so 5 would be the answer to the question, since they're asking how many different lists are there. The figure called a net has dimensions as shown. This net can be folded to form a rectangular prism. What is the volume of the prism? Well, let's label this. If you were to fold this up into a box, let's just say that this is the bottom, the base. So I'll just label that length and width. And therefore this would also be width, that's width, and then obviously that's length, and then so on, right? And then this would be the height, because that flap will be, folded upwards, and then it would represent the height. So similarly, that's going to be H, because that's going to be the same kind of story. This will be L, this will be H, and so on, right? We're just kind of labeling this to make it match L, L, and so on. So what we can do from that, I think we'll label a couple more here. This will be H, and this will be H, these sides, is that we can use the numbers that they gave me to kind of make some equations. So the W plus L, that is 14. So this W plus this L is at 14. And then the W plus H, that's 11. So this W here plus that H is that 11. And then all the way across, that 38, Let's see here. That's going to be H plus L plus H plus L. Okay, so we've got our equations, and now we just have to solve them. So from this guy, that's going to be 2H plus 2L is 38. So that basically means that H plus L is 19. H plus L is 19. Yeah. Okay. I think I'll just use this guy and sub in these two. So H, if I use that, would be 11 minus W. And L, if I use this one, will be 14 minus W. So then I can get everything in terms of one equation, and I'll be able to solve this. So this will be 25 minus 2W is 19. So that means 6 is 2W, so therefore W is 3. And then to get the values for the other guys, the L and H, I just plug them into here. So when I plug it into there, L would be 11. And when I plug W equals 3 into there, H will be 8. And then what are they asking? Oh, the volume of the prism. Well, the volume of a prism is length times width times height. So that's going to be 11 times 3 times 8. And 11 times 3 times 8 is 264. Gary and Deep play a game in which there are no ties. Each player is equally likely to win each game. The first player to win 4 games becomes the champion, and no further games are played. Gary wins the first 2 games. What is the probability that Deep becomes the champion? Well, let's see here. We've got Deep and Gary. And Gary wins the first 2 games. So let's see here. And what do they want? The first person to win 4 games. Okay. So you could have a scenario where Deep wins 4 and Gary wins 2. Well, Gary's going to win 2 for sure, since that's already been told. Like, that's going to happen. So the total games is 6 in this case. Or Gary can win 3 and Deep wins 4, and then the total is 7. And is there any other information they're giving us? Because I'm trying to think here. I think that's it. I think these are the only 2 scenarios. Because if we go to 4 games, then Gary would win. And we want Deep to become the champion. So this scenario would not, be part of the solution. So I think these 2, either it's 4-2 or 4-3, are the only ways that this could happen. Okay, so let's talk about this then. The first scenario, which is the 4-2 situation, Gary wins the first 2, and then Deep wins the next 4. And that would result in Deep winning. Now, the probability of this happening, the first 2 are kind of a given, so that's actually doesn't even play a role in our calculations, because that's sort of a given. We have to figure out the probability of 4 in a row for Deep. And his probability of winning 1 game is a half, right? Because each player has equal likely to win a game. So the probability of this happening is a half, that happening is a half, that happening is a half, that happening is a half. So you have to multiply them all together, and when you do, you get 1 over 16. So the probability of this scenario is 1 over 16. Okay, so that takes care of this guy. Now we got to concentrate on this one here. So that one is 3 and 4. So something like this. That's one way of doing it. But here's the thing. That third G is not fixed. The first 2 G's are fixed, because that's what the question tells you, that Gary wins the first 2 games. But that third G could happen here, or it could happen here. Or how many scenarios do we have for that third G? And it could happen here. Yeah, because it can't happen at the very end, because that by that point the game would be over. So D, 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 this is a scenario, D, 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 and then 3 Ds, if I did this right, and then a D, yeah. Okay, so that's the only ways. Okay, so let's talk about this. So as always, the first two are fixed, so they don't contribute to the probability. All right, the probability of this g is a half. That's a half, half, and a half. So you multiply them all together, and when you do, you get 1 over 32. So the probability of this scenario is 1 over 32. And in a very similar way, all these other guys would be 1 over 32 also. And I think that's it. So now to get the full probability, you add up all these guys. So you add up that, and all those. So the probability would be 1 over 16 plus those 4 1 over 32s. And I believe that is correct. So let's do this math here. 1 over 16 plus 4 over 32 is what? 1 over 8? Yeah, 1 over 8. So then that's 1 over 16 plus 2 over 16, and that would be 3 over 16. So 3 over 16 is the final answer. A 9-digit positive integer n is called a Moffat number if its digits are 0, 1, 2, 3, 4, 5, 6, 7, 8 with no repetition. The sum of each group of 5 digits in a row is divisible by 5, and the sum of each group of 7 digits in a row is divisible by 4. For example, 5, 7, 8, 4, 6, 0, 2, 1, 3 is not a Moffat number because while the sum of each group of 7 digits in a row is divisible by 4, not all of the sums of groups of 5 digits in a row are divisible by 5. Determine the sum of all Moffat numbers. If you have a number that is a Moffat number, so it would be 9 digits. So 1, 2, 3, 4, 5, 6, 7, 8, 9. And let's label it N1, N2, and so on. And then let's talk about their divisibility properties. And maybe we will go somewhere with that. Okay. So they're saying the first thing is that each group of 5 digits in a row is divisible by 5. So for example, the first 5, if you were to add them like that, they would be divisible by 5. So that would mean there would be some multiple of 5, say 5k. And in a very similar way, the next 5, if we were to add those guys, they would also be a multiple of 5. So 5, whatever, 5t, let's say. And so on. You guys get the point. And if we look at this rule, that rule states the same kind of story, but this time for 7 integers in a row. So that would be n1 plus n2 all the way up until n7. That would be divisible by 4, so let's say 4m, and so on, right? So what we can do is we can take these guys and come up with some sort of, I guess, some conclusion as to what they could be. So if I subtract those two, for example, if I take this guy and subtract from it this guy, everything will be vanished and we'll just be left with n1 minus n6, and it'll be 5k minus 5t, which basically is 5 times k minus t. And what that tells me is that the difference of n1 and n6 is divisible by 5. So, for example, if I have n1 and n6, and remember we can only choose from those digits, the subtracted value would be a multiple of 5. So for example, if this was 5, this would be a 0, because 5 minus 0 is 5, which is a multiple of 5. If this was 6, this would be 1. And if this was 7, this would be 2, and this was 8, this would be 3. Those would satisfy essentially what that equation is telling me, that the difference between n1 and n6 is a multiple of 5. So that's sort of where we go. Well, at least that's sort of where we go so far. And this kind of thing can be extrapolated, like we did it for n1 and n6, and you can do the exact same thing. So similarly, you can do the exact same thing for n2 and n7. Right? Same way, you just take n2 to n7, and then Well, actually, I think I'm going to have to show you. So, for example, we just did this up there, right? So we can do, say, n1 plus n2 plus n3 plus n4 plus n5. That minus n3 this time plus n4 plus n5, n6 and n7. Now, both of these, according to the rules of the question, are divisible by 5, right? So their difference will also be divisible by 5. So it'll be some multiple of 5, whatever, 5j, let's say. I'm running out of letters here. Now, if I do this subtraction, I have n1 plus n2, and then n6 minus n7. Now, n1 minus n6, that's this guy right here. So I can put that in there, 5k minus t. And then I'll be left with n2 minus n7 is 5j. Now, if I just leave the n2 minus n7 on one side and then put all this over there, it'll become j minus k plus t, I believe. So as you can see, n2 minus n7 is also a multiple of 5. So same kind of story, just like how I did up here, I can do the same thing here. I can write 5, 0, 6, 1, 7, 2, and 8, 3 as possible values for n2 and n7. And the same kind of story is true for n3 versus n8 and n4 and n9. So that is how we will kind of come up with values for these digits, I guess. 5, 0, 6, 1, 7, 2, 8, 3. Okay, so now that is established, let's talk about this a little bit. If you notice in these numbers, every number is there except the number 4. So for n1, n6, n2, n3, n4, everything is there, but n5 is missing. And in the numbers, everything is there except the 4. So by conclusion, we can state that n5 is the 4. You got it? Because that's the only one that's remaining. So we made some progress there. Okay. Now we turn our attention to this divisibility rule, the one with the 7s. And in a very similar way, you can conclude with the 7s that n1 minus n8 is a multiple of 4, and then n2 minus n9 is a multiple of 4. Very similarly, you write it all out and you subtract them and you get the same thing. So just like how we did up there, we'd have n1 and n8, and we'd have also n2 and n9, and when you subtract them, they have to be a multiple of 4. So for example, if this was, say 1, this would have to be a 5, because the difference is a multiple of 4. So that's sort of how you would approach that. And, or I think, let's see here. Yeah, 1 and 5. Yeah, because 5 minus 1 is 4, right? 4 is a multiple of 4, obviously. Okay. So I think so far we are doing pretty good here. So now let's come up with an example. So let's see if we can at least come up with one Moffat number. Okay, so we concluded that n5 is 4. So this is n1, n2, n3, n4, n5, n6, n7, n8, n9. Okay, so we concluded up here that is 4, so that's going to be a 4. Okay, now we have to sort of decide, n1, what can it be? Let's say it's a 1. Okay, if n1 is a 1, then that means that n8 must be a 5 in order to satisfy that divisibility rule. All right, so that's pretty decent. And then now where do we go from here? Well, n1 is a 1. So that means if we look up here, n1 and n6 have to have a difference of 5. So we're going to use this scenario where n1 is the 1 and then n6 is the 6. So that 6 goes here. And then anything else? Well, we had selected n8 to be a 5. So that's this scenario here. So that means 5 and 0 are what n8 and n3 have to be. We just reversed them. So that it means n3 is a 0. So hopefully that makes sense. Hopefully that wasn't too complicated or confusing. But we still haven't filled out the whole number. We still have a couple of gaps, right? And also, I started with n1 equal to 1 and kind of went through all the stuff I did up here, right? All this stuff here. But I could have started with, say, n1 equal to 2 and so on, or n1 equal to 3 or 4. Well, it can't be 4 because that is not one of the choices, but it could be 5, 6, 7, and 8 for the value of n1. And if you choose those values for n1, then you'd get the following numbers. Well, the first one I already did. For 2 would be 2, 1, 4, 7, 6, like that. And I'm fast forwarding. I'm not walking you through it, but I'm just saying that just like how I did it up here, if you go through all those divisibility rules, this is the number you'd get. And I'll fill them in now. And those would be the numbers. But obviously, as you can tell, I haven't listed the full number. There's still some blanks in there. So we got to figure out the blanks. And once we figure out the blanks, then we can add up all the Moffat numbers. And I believe there's going to be 1, 2, 3, 4, 5, 6, 7, 8, right? 1, 2, 3, 4, 5, 6, 7. Huh. Is there one missing here? 1, 2, 3, 4, 5, 6, 7, 8. I think what happened here is that some of these are not possible. Like, for example, if n1 is 2, like this example right here, this thing falls apart. Because if n1 is 2, then n2 is 6, and which is not possible since n8 is 6. Yeah. Yeah, so let me see if I can explain that a little bit better. So for this one, when I filled this in, you have n1, n2, n3, n4, n5, n6, n7, and n8, right? So n8 is, in this case, 6. So if we go back to our little table here, n8 right here, if n8 is like a 6, 1 combination, that would mean that n3 would have to be 1. We just have to reverse it. So that would mean that n3 would have to be 1. But we have already placed that 1, so right here, so that works. So there's actually a divisibility rule that we have to implement or talk about. If we look at all the numbers, right, the numbers are 0 all the way till 8, I believe. So if you add those up, you get 36. Now we know that any consecutive string of 7 is divisible by 4. So that would mean, say, that n3 all the way till n8, or n9 I should say, those 7 will be divisible by 4. So 4k, let's say. But this 36 is also divisible by 4. Yeah. So that means that n1 plus n2 should also be divisible by 4. That's the only way that if you add these to that, that would make it all divisible by 4. Hopefully that makes sense. So this is very important. So that means that if you add n1 and n2, they've got to be a multiple of 4. So that means that if you look at this guy again, the n2, in this case, the only possibility for it is 6. but 6 is already used up there. So that's why this falls apart. So it's a little bit of a complicated explanation as to why that falls apart. In a very similar way, when n1 is chosen to be 6, which is this guy up down here, n2, let's see, would have to be 2, right? In order for that divisibility rule to work. But you've already used the 2, so that falls apart. And then when n1 is 8, which is this one up here, n2, with regard to the remaining digits, the only possibility is 0, but 0 is already used up there, so that falls apart. So that's why we have limited choices here. n1 can only be 1. It can only be 3. It can only be 5. And it can only be 7. So that is how we have to look at this. So it can only be like that, like this, or like that. So, okay, so now let's move on. Again, we still have to fill in the blanks here. Okay, so let me show you how to fill in the blanks, and let's start with the first one. So the first one was a 1, and then a blank, and then a 0, and then a 4, and then a 6, and then a blank, and then a 5, and then a blank. Okay, so let's fill this one out, and that'll give you an idea of how to fill out all the other ones. Now, we have a limited number of digits. It's 0 through 8. So we put 5 in there so far. So the ones that are missing for this particular example are the 2, the 3, the 7, and the 8. Those are the ones that we have to place. So we have to figure out, how do we place these? Okay, not a problem. We just look back up at these rules here that I created. And when we do, we find that there was one rule that the n9 and the n4 had to differ by 5. So this is n1, n2, n3, n4, n5, n6, n7, n8, and n9. Now we, let's see, n9 is here and n4 is here, right? So we got to choose 2 from there that differ by 5. Well, I got a couple choices. Looks like we can use either the 7 and the 2 or the 8 and the 3. Yeah. Either a 7 or a 2 or an 8 or a 3. Okay, let's use the 7 and the 2 first. Let's see what happens. So I put the 7 here and the 2 here. So that would mean 7 goes here and the 2 goes here. Okay, so I've taken that. And then what's left is n2 and n7. And those have to differ by 5 also, based on the rules. Well, we got 8 and 3. Okay, so I put the 8 here and the 3 here. And that would mean this is a 3 and this is an 8. Yeah. Now, some of you watching this will probably say, well, isn't there other ways of doing this? And the answer is yes, there are. So, for example, for the 1, it could also be a 17084625 when n1 is 1. And similarly, you're going to get, so I got 2 for this guy right here. You're going to get 2 for this, and 2 for, what was the other one? 7, right? So I'll just write them all out for you. So this is my first complete Moffat number. This is my second complete Moffat number. And then the other ones, 3, 1, 2, 0, 4, 8, 6, 7, 5. I'm not going through the whole process with you. I'm just writing them all out because I think you can figure out the blanks by just going through the process yourself. And then once we have all the Moffat numbers, we can just add them up, and that will give us the sum of all the Moffat numbers, which is what the question is asking for. And 642,031. So this 642,031. So this 1, 2, 3, 4, 5, 6, 7, 8. Okay, 8 Moffat numbers. And then we add them all up. And when you do, you get 3, 555555552. I believe so. 2, 3, 4. 1, 2, 3, 4. Yeah, I think that's the sum total. So that would be the answer to the question.